Hello and welcome to the Writing Glitch. Sherry is on vacation through the end of the year, so I am here to take over the podcast for today. We will not be posting any episodes Christmas week or New Year's week. Check back in January for our next episode. For now,
sit back and let Teresa take over and do a summary. Teresa, Go for it.
This is purely from the text. We're talking about the central nervous system. It includes the brain and the spinal cord, and then the nerves that leave the spinal cord. So the brainstem, that's where all that autonomic responses occur. The part of the brain, now that's that oldest part of the brain, and it controls parts of that automatically excite and calm the bodily reactions. So the autonomic nervous system is where that's occurring. The breathing, the body temperature, and the heartbeat. The brainstem, they even call it reptilian because it's the oldest. One of the points that it was made in the book is that it can be overridden by other parts of the brain. Plain and simple. The cerebellum.
Before you move on
Go ahead.
From the autonomic,
Yes.
there's a term that we as OTs hear. For Paula, you probably never heard this word. Interoception. I'm going to put it in the chat.
Oh, perfect.
The autonomic nervous system and interoception are integrated together. And as soon as you started talking, my brain went back to the day that I was writing that section of the book. I can tell you exactly where I was when I was writing the section on autonomic nervous system. Would you like to know where that was?
Sure.
Where were you?
I was at Wegmans in their section of the restaurant or the supermarket. It's one of those supermarkets that has a section that you can eat on the side. So they have a big takeout section and you go buy your food and then you can go sit and eat. One of my children was at school. My kids went to school an hour from home. And they didn't go every day. They were mostly cybered before cyber was a cyber. My daughter had to actually go into the building that day, and I wasn't allowed to stay at the building during the event. I went over to Wegmans. I don't know. It just hit me like crazy. And I know it's a bizarre side note, but when you start to do this, it becomes ingrained. Thank you, Teresa, for that memory moment. But when you're thinking about the autonomic nervous system and you hear the word interoception, think about that whole nervous system being intertwined together.
Yeah, it's that gut instinct that tells you, I need to go to the bathroom. I need to do this. It's automatic and it's almost things you can't control. If you ever have that gut feeling, like something worries you, that's where, Sherry, we've gone into that a lot more recently, but it's also those things that the kids don't understand as much as you think they should. And that's when those kids get more worrisome and when things like that occur. I had a child at school who had bathroom issues. That's part and parcel of sometimes why they don't excel or do things in school because of that. And it gets to be an issue sometimes. The interoception takes over their lives. And it's hard to believe that's something that occurs, but it does until they understand how to handle that. The cerebellum is part of the brainstem. It's the largest organ. It's the refinement center, and it makes meaning out of the movements we do, and it smooths it out. It's refining everything. If you thought the brainstem was the beginning and then it filters through and it refines everything, it makes it smoother. Children with dysgraphia have difficulty with smooth lines when writing. They tend to be jerky within their marks, and the result is frustration and refusal to write. We see this all the time. These movements may be the result of cerebellar pathway dysfunction. You got to get back to the roots of where this child is having difficulty. The limbic system, as you move forward into the brain, from the brainstem, the next section is the limbic system. That's the center of the brain, and it controls our emotions, short-term memory, and codes our movements into files. Sherry's got this down. She talks about the filing system. Each movement becomes associated with our emotions. That's where that movie comes into play, where here's the filing cabinet. We talk about how a kid, if they're writing and they just pretend it's on fish and they can't get that down. Anytime you bring forth this, let's write about fish, they're going to be, I don't ever want to talk about fish again. I'm not writing blah, blah, blah. You've put a bad memory with the writing, and they will never, ever want to write about fish, because that's the bad memory and they couldn't write it. So they'll never, ever want to write about fish again. I know it seems weird, but you've put a memory with an emotion, and forget it. They will never do it. In this case, it's, if they were proficient at hitting that baseball, you gave them an awesome memory and they'll love it forever and they'll be so proud of it. Every time they go up, they want to hit that baseball. But if it was a bad memory, then they'll think of themselves as a failure and they won't want to do it. It's tying an emotion and a memory together. That's what the limbic system is doing in our brain. They're calling it the emotional heart. It's either tying a good memory or a bad memory to an emotion. The amygdala is the center of fear. The brainstem responds in the fight, flight, fright response. It's located just above the brainstem in the center of the brain, and it relays messages down to the brainstem, but also to the hippocampus and other parts of the brain. It helps the autonomic nervous system, and it can release cortisol in situations of excitement. The hippocampus, that's your short-term memory center. There's a right and left portion, and all good and bad memories flow through this location. It links our memories to an emotion that are generated in the amygdala, and it takes what's happening throughout the day and stores it. This is a quick access file, is our working memory. It keeps our daily memories in segmented files by time until we sleep. This is why sleep is so important. During sleep, the memories in the hippocampus are filed in the long-term memory center, and before it gets moved to the thalamus. And then when you sleep, the short-term memories are converted to long-term memories. People that have trouble sleeping may never get to a REM sleep, and therefore never move their daily memories to the long-term memory bank. That's pretty sad. That, so if something occurred and you, oh, do you remember that? And it may not have gone where it's supposed to, so that those people never get to that point of it storing. Maybe it'll store eventually, but if they don't have that good sleep, these kids may never get to that point of putting stuff in long-term memory. You may see this, even Paula too, with those kids who are not getting those, you taught them something, it's not storing. Check with their sleep, check with the parents. You ask the parent, when we had the kindergartens coming in for intakes, how would their sleep? It might be those strange things that you talk to somebody about, and the parents, what do you mean sleep? I'll be at an IEP meeting. How is their sleep? And the parent would be like, oh my God, they're horrible sleepers. How many times do we find we're sitting at an IEP meeting and the parent says the kid takes melatonin? Automatically, their sleep is poor. If you think back and their memory issues, or the fact that you have to keep repeating a lesson to them, that means that they're not getting it. And that's why you have to support what they're learning with cues or prompts all the time. That may be something to focus on so that they'll get that into the long-term memory. It's so important. It happens with us. It happens with the kids just as well. The thalamus resides on the top of the brainstem, and it connects the brainstem and the limbic system, and it is the gatekeeper of the limbic system. It filters the sensory system from all peripheral sensory systems. It is the major role of the thalamus to control whether the person is awake or asleep. And second, it filters visual stimulus to the occipital lobes. And third, it regulates auditory information that is sent to the auditory cortex. The thalamus is pretty important. Finally, it coordinates motor control, coordination, and modulates the intensity of movement and motor planning. If a kid is all messed up, this may be what's going on. Information is sent to many areas of the cerebellum and cortex. This information allows the brain to associate individual pieces of information with other pieces of data into a message that is sent to the basal ganglia. The thalamus is going to be a wicked important, being that it's a gatekeeper. It has so many functions, is critical in our brain function. The basal ganglia is a group of tissue masses near the hippocampus that takes movement patterns and supports the hippocampus and the amygdala to convert movement from short-term memory and move them to long-term memory. And the basal ganglia tells us what to do with the information that is processed. It converts the cognitive information from the cortex, refined movements from the cerebellum and emotional and memory connections of the limbic system and relays it to the body. The neural pathways do all the communication in a millisecond. When it does not work smoothly, reactions like tremors or jerky behaviors. The basal ganglia converts the information, but I've had a child who has, in some cases, the jerky behavior, and you can't, it's not CP, and it's definitely not a condition. We couldn't tell what it was. It definitely could have been from the basal ganglia that the information wasn't processing well enough for her to stop those. It was almost intention tremors, but it was unknown etiology for her to do that. Definitely.
I want to pause and I want to ask a
Yep.
question about the
Go
basal
right ahead.
ganglia. Beth, did you learn a whole lot about the basal ganglia in college?
Not in school. It was all information that I went back and learned on my own. Sensory integration was
Teresa,
my
yeah.
beginning, and I learned a lot there. But now it was never, even when you're learning it that way, it was never tied to outward motor coordination. It was more tied to, back then, 20 years ago, 15 years ago, it was more tied to the sensory inhibition and self-control and more of that, and the integration of all of our sensory systems, more than tied to movement responses that you see outwardly, that we would notice, that our clinical reasoning would go to.
And Teresa, would you concur on that as well?
Yeah, I agree. I've told Cheri should know more than anything that as soon as you read through this, it made more sense because it didn't before. It was just parts of the brain before. It didn't make enough sense to connect one piece to the next piece.
Mm-hmm.
When I was doing the research on the basal ganglia and trying to find out what was new about it, I had learned some of this stuff. I went back to my books from school. Now, I was in school 32 years ago. The amount of information that the neuroanatomy textbook had was 2 sentences.
Mm-hmm.
That sounds right. It was terminology more than function.
Yes, I agree.
They know so much more today than they did. Now, I had to extrapolate a lot of information because they're doing much more research in the basal ganglia on adults. That's where the issues are coming from with Parkinson's disease. But there's also some other similar diseases that are being, the origination is the integration of from the basal ganglia down to the motor function. I wanted to pause there and take that moment for you to have that realization that, yeah, we didn't learn much in school. Paula, I want you to also hear that we even as occupational therapists did not learn enough about the basal ganglia in school because they didn't know.
Yeah.
My student, I did do the same thing. I did the research on her, and she had unknown etiology for why she was having the jerkiness and the tremors, and why you knew she had intention tremors. I even gave her a weighted mitt and weighted cuffs on her wrists. But why was she having it? She didn't have no anoxia when she was born, none of those classic symptoms that you would have seen, but could it have been the basal ganglia? Who knows? There wasn't a lot of research, like you said, done, but it could very well have been something going on there to give her these issues because no one looked into it.
Yeah. The other new research that is out is about the cerebellum. If we back up to the biggest part of the brain down under the occipital lobe, the cerebellum, what they're finding is there is a direct link to learning. The more jerky a kid is, the less likely they are to learn. And with trauma, the cerebellum shuts down.
Mm-hmm.
It doesn't work. There's this disconnect between learning and trauma because of the cerebellar shutdown. Why it's shutting down, it's a protective mechanism. But other than that, they aren't quite sure. But a lot of the new therapies that are out there are stimulating the growth and the reactivation of the cerebellum, which is re-engaging kids in learning. I don't know if you knew that,
It
Beth.
makes a lot of sense. It does. Because look where the cerebellum assists the hippocampus and the basal ganglia and the limbic system.
We're going to stop there. The remaining parts of this discussion, about another hour, are included in the book study course for Handwriting Brain-Body Disconnect. The link to Disability Labs is in the show notes, so you can learn more. We hope you have learned from this segment. Go be awesome. Go be brilliant. You were put here for such a time as this. I look forward to hearing from you about how this episode changed your perspective. Send us an email at info@cheri.com. Don't forget to hit that subscribe button. Thanks. Merry Christmas, Happy Hanukkah, and Happy New Year.